Now let's take a look at vector operation in two dimensions. So before we go further into adding and subtracting vectors in terms of I and j, so you have to get yourself familiar with this law, which is triangle law of vector addition, based on the illustration that I've sketched over here. Triangle law of vector addition says that if you have this kind of setup, vector AB plus vector BC is equal to vector AC. So if you get this fact right, by right, when we throw what kind of question, you will end up knowing on how to solve the problems. So you may take a look at all the examples listed in the slide presentation. So I really hope you can work on your own, but right now I would like to discuss about this exercise. So basically you have been given with this diagram that has information of point A, point B, point C, point D, and vectors P, vectors R, and vector Q. So let's take a look at this exercise. So basically you have been given with the information of vector AP is equal to vector P, vector BD is equal to vector Q, and vector CD is equal to vector R. So by using all this information, the question asks you to express or determine vector P, vector BC, vector AC, and vector AD in terms of vector P, Q, and vector R. So let me sketch the diagram once again. So imagine you have this diagram, alright, and then you have this vector P, and you have vector Q, and you also have vector R. Alright, so let me label all the vertex such as A, B, V, and C. Alright, so okay, let's try to determine vector BC. Alright, vector BC can be obtained if I have this kind of expression such as vector VBC plus vector CD will give me vector BD. So in this case, we are not sure what is vector BC. Vector BC, we will write it as vector BC, but we know that vector CD is vector R, and vector BD is vector Q. Then straight away vector BC is equal to vector Q minus vector R. So that is the answer for the first question. And then the question also asks us to form vector AD in terms of vector P, vector Q, and vector R. So vector AD. So in this case, vector AD can be found by using this expression. AD is equal to vector AB plus vector BD. So in this case, vector AB is vector P plus vector Q. So we have solved the second question, and then the question also asks us to determine vector AC. Alright, vector AC can be found by using this expression such as vector AB plus vector BC. So we know already that vector AB is represented by that vector P, and when we try to solve this question, we have managed to determine vector BC, which is vector BC is equal to vector Q minus vector R. Then vector AC is as simple as vector P plus vector Q minus vector R. So this triangle law of vector addition will be useful when you have this kind of problem that asks or demand your creativity in solving it. Vectors in two-dimensional coordinate system can be added or subtracted, and it is easy for you to perform the operation according to the component. As mentioned over here, if you have two vectors, namely vector u and vector v, that consists of a, b, and c, d respectively, if you can see clearly, when I want to perform the addition and subtraction, I will do it according to the component, which is horizontal with horizontal component and vertical with vertical component. And as you can see from here, other than addition and subtraction, you can also perform scalar multiplication of vectors, which is scalar can be any number. But multiplying a vector by a scalar changes the magnitude of the vector but not the direction. So I hope you can get this idea accordingly. Now let's discuss about unit vector in 2D. A unit vector is defined as a vector which has magnitude 1. For example, this vector v that consists of I plus 2j is not a unit vector, since if you are trying to look for its magnitude, you will end up having 1 squared plus 2 squared, which is 5, set 5. Okay, set 5 obviously not equal to 1, which is contrary to the definition that we have presented earlier. For example, the following example v that consists of 1 over set 2 for both I and j component of the vector is indeed a unit vector, since if you are trying to look for its magnitude, you will end up having 1 as the answer. In two-dimensional coordinate system, basic unit vectors are I and vector j, which are of length 1 and have direction along the positive x-axis and y-axis respectively. This is what I have explained earlier when we discussed about the introduction to vectors in 2D. To find a unit vector with the same direction as a given vector, we divide by the magnitude of the vector. For example, if you have this vector u is equal to ai plus bj, and then the notation of unit vectors is given as u hat. Vector u hat equal to vector u divided by its magnitude, which is aligned to the definition given for a unit vector with the same direction as a given vector. Now let's take a look at this example where the question asks us to determine a unit vector of the same direction for the given vector v, which is 5i minus 12j. Then the question asks us to also verify the magnitude of the unit vector is indeed 1, which is aligned to the definition of unit vector, which is the unit vector always has magnitude 1. So right now, what are we going to do is that we have to recall the formula to determine unit vector in the same direction as the given vector, which is vector v hat equal to vector v divided by the magnitude of vector v. Since we know already the vector v is equal to 5i minus 12j, therefore we have to use the formula to determine the magnitude of the vector v, which is horizontal component squared plus vertical component squared, and then you find its square root. So in this case, the magnitude of vector v is equal to sec 5 squared plus 12 squared, which is sec 169, which is equal to 13. And then we put it into the formula, which is the unit vector v vector v hat equal to the vector itself, vector v, which is 5 and negative 12 divided by 3, or you can transform it in this notation, which is 5 over 13i minus 12 over 13j. And then our job is not finished. We have to verify that the unit vector v hat equal to 1, the magnitude itself. So in this case, you also use the formula to determine the magnitude of vector, which is a squared plus b squared, and then you find its square root. So you are able to show that the unit vector v is indeed 1, hence verified. We are used to describing vectors in component form. For example, if we have vector v is equal to 3i plus 4j. We can plot vectors in the coordinate plane by drawing a directed line segment from the origin to the point AB that correspond to the vector's component. As you can see from this illustration, for example, this is the common vector in coordinate plane. And then if we try to relate with what we have learned from the previous topic or chapters, so basically if I decide, since this can be related to right angle triangle formula, and then try to recall, if we try to determine cosine theta, you will have adjacent over hypotenuse. In this case, the adjacent is obviously the length is a, and the hypotenuse is actually the magnitude of the vector, which is the magnitude can be determined by using the formula sec a squared plus b squared. Then by making a as the subject of your equation, you will get a is equal to magnitude vector v cosine theta. And then if you try to determine sine theta by using the formula, you will end up having opposite over hypotenuse. Again, the length of the opposite is b, and then the length of the line segment that connects the origin and point AB, obviously the magnitude of the vector, which is magnitude vector v. And then by letting b as the subject of your equation, you will end up having b is equal to magnitude of vector v sine theta. Then try to recall, when you have a vector in coordinate plane, you will end up having vector v is equal to ai plus bj. And therefore, we replace every component form, which is a and b, into whatever we have discussed earlier, which is a you replace with magnitude vector v cosine theta I plus magnitude vector v sine theta j. Now let's take a look at this example. The vector that represents the direction and speed of an object motion is called velocity vector. In this example, the wind's velocity is expressed in terms of wind's magnitude and direction. So the wind is blowing at 20 miles per hour in the direction north 30 west. Express its velocity as a vector v in terms of I and j. So right now you have to recall, when you try to read a compass by right, you will have these four crucial elements that represent north, east, south, and west. So it is always measured from vertical axis, north-south axis. So if the question given the wind is blowing at 20 miles per hour in the direction of N30W, it means 30 degree from north to the direction of west. So imagine you have this as north, so it will move 30 degree to the direction of west. So hence explain why we have this as our theta, because theta is always measured from the positive x-axis. So in this case, 90 degree plus 30 degree is equal to 120 degree, or equivalent to 2 pi over 3. So other than that, based on the information given in the question, the magnitude V is actually 20, which we obtain from the wording, the wind is blowing at 20 miles per hour. And then we substitute into the formula of a vector in terms of its magnitude and direction, which is vector V is equal to magnitude vector V cosine theta I plus magnitude vector V sine theta j. And then you substitute, and then you'll end up having this as your answer. Then you have successfully answered the question.